Hey, hello, everyone. My name is Mustafa, and I'm the co-founder of Celestia. And today I want to talk to you about Celestia, which is a pluggable consensus layer for blockchains to enable anyone to deploy a blockchain really easily. Bit of background about myself. Um, I was previously a PhD researcher at University College London, working on layer one blockchain scalability techniques such as sharding. And I was also previously a co-founder of Chainspace, which was one of the first sharding projects in blockchains. And that company was acquired by Facebook, but I was the only researcher there that did not go to Facebook. So what is Celestia? Celestia is a pluggable consensus and data availability layer. We're going to talk about what that means in this talk and why that's important. But the key idea here is what we're trying to achieve is to enable anyone to really easily, quickly deploy their own blockchain without the overhead of having to create their own consensus network from scratch using something like proof of work or proof of stake. Whereas now it would take a very long time or months to build a consensus network to deploy a blockchain. We want to really crunch that process down to a few minutes by making it really easy and providing a pluggable consensus network. And one of the key reasons we're doing this is because we want to create a world where global digital communities can effectively self-organize in a completely sovereign way um, using decentralized networks without being burdened by existing power structures. And that could also include being beholden to the rules of another layer one network. For example, if you're deploying a smart contract on an existing layer one, you have to follow the rules of that specific network. And we're going to talk about why that's not good and why we're trying to change that in this talk. So if you look at existing blockchains today, are very monolithic. They try to do everything at the same time. So there's several layers to a blockchain. If you look on the left, existing blockchains today, they provide on the base layer, on layer one, they provide both consensus and data availability and execution. And so you, for example, if you look at Ethereum, for example, you write your smart contract and you deploy your smart contract onto Ethereum, and Ethereum provides everything for you. It provides the consensus and it provides the execution, which is the Ethereum virtual machine. So you have to write all of your applications in such a way that the Ethereum virtual machine understands it. And that's quite limiting in terms of what you can do. Not only from a technical perspective, in terms of being limited to the technical limitations of the Ethereum virtual machine, but it also means that your smart contract is sharing the same execution environment as every other smart contract, which is similar to if your computer program is running on the same computer as everyone else. And so that means you're bound by this kind of shared social contract of all Ethereum users. So if, for example, you wanted to change the rules of your smart contract, let's say there was a hack, or for example, like the DAO, you have to convince the entire Ethereum community to hard fork the entire chain and every single contract. So it's not a very sovereign way of creating your own sovereign applications, because you're bound by the rules of other contracts that you might not necessarily care about. But what we're trying to do is trying to make the blockchain stack more modular and decouple some of those layers. So what we're trying to do is decouple the consensus layer from the execution layer. And what that means is that we're trying to provide a very simple base layer blockchain that only does one thing, which is consensus and data availability, which is just the core things that blockchain needs to do. And that gives developers the flexibility to define their own execution layers on top in the form of their own blockchains. and it gives them a lot more flexibility and power that hasn't been possible before in the decentralized application space. We can compare, one of our theses is that we can compare the evolution of the blockchain space to the web. So if you look at the early web in the 90s, when HTTP or the web was first created, if you wanted to create a website, you had to basically have your own physical server, for example, in your bedroom or in your university. And then shared hosting providers came about. I don't know if everyone remembers services like GeoCities or DreamHost or Bluehost. You would basically upload your code to this shared server, and your website would run on the same server as everyone else. And then in the modern web, we have virtual machines or the cloud. So now anyone can easily spin up their own server, kind of like the 90s, but without actually having to go through the overhead of having a physical machine. You can spin up your own server on something like AWS in minutes and have complete flexibility and control and sovereignty over how you create or deploy your application. So we're seeing a similar evolution in the blockchain space. So when Bitcoin came around in 2008, there was this idea of like each application had its own blockchain. So Bitcoin had its own blockchain specifically for cryptocurrency or for the Bitcoin asset. And then you had things like Litecoin, Namecoin, Mastercoin, and those were basically providing like a blockchain for each application. And then Ethereum came about in 2014 and provided a general purpose blockchain that allows people to upload any application to share the same chain. And that made it easy for people to create their own smart contracts and upload it. But that has severe limitations, similar to the limitations of uploading your website code to a shared web hosting provider like GeoCities, because you have very limited flexibility in how you can actually develop your website and what it can do. So what we're seeing now is a trend towards back to people creating their own app-specific chains or their own chains for their own applications. But instead of having to create their own applications from scratch, they can deploy their chains on existing or pluggable consensus layers, similar to how today you can deploy your own virtual machine on AWS using physical servers that they have. From a technical perspective, I'm going to discuss the way that Celestia works. So existing blockchains today, in order to check if a block is valid, you basically have to check two things. Number one, you have to check if the block has consensus, i.e., if it's proof of work, for example, does the chain have enough proof of work for it to be the longest chain? Or if it's proof of stake, for example, or using Byzantine fault tolerance, have 2/3 of the validators sign the block. That's the first thing. And then the second thing is that you have to check if the actual transactions in the block are valid. Like you can't just insert a transaction into the chain that steals everyone's money. You should reject that block. And so effectively, current blockchains are coupling the rules, the execution rules for transactions with the rules for the consensus. And this doesn't scale because the problem with that is that in order for users to check that block is valid, you have to download and process every single transaction to check that a block is actually valid. But what if you actually remove that second rule? Like, what if you said like you're allowed to post invalid transactions on the chain, and anyone's allowed to post anything on the chain? Would the chain still be secure? The intuition is yes, it will still be secure, because what you can do is you can insert an implicit rule on the actual user's machines to say that if they see an invalid transaction, they just ignore that transaction. So if there's a transaction that steals people's money, even though that transaction is on the blockchain, you just ignore it when you're trying to process or compute everyone's account balances. So, however, even if you ignore the transactions that are invalid, you still have to make sure that the miner or the block producer has actually published all of the transactions in that block. So you don't want to end up in a situation where, for example, here, a miner has published a block, but has not actually published the transactions inside that block. Then people with sovereign or independent roll-up applications or decentralized networks that are not necessarily tied to the Ethereum ecosystem. And this is like more of a general question because we're living in a more and more like multi-chain ecosystem where like most transaction volume on Ethereum now is not even on Ethereum, it's on Polygon. Like people are just like transferring assets from Ethereum to Polygon and just doing the transactions there and then transferring it back to Ethereum. So because like we're living in a multi-chain ecosystem, solutions like this will become more and more relevant, and a general purpose data availability layer will become more and more important. You have a follow up or yeah?